Cholera is a devastating disease. It can occur rather suddenly, and it's a disease caused by a bacterium, Vibrio cholerae, a vibrio that causes cholera. And that means that an individual who drinks water contaminated with the bacteria, I shouldn't even say contaminated, with the bacteria present in it, but water not purified, then the individual might, in a matter of hours, begin to feel nauseous, have diarrhea, and this will progress, in the case of a complete case of cholera, to severe dehydration, and that ultimately will result in death. Now, we can't eradicate cholera. We can eradicate some diseases. Smallpox theoretically has been eradicated, but Vibrios are part of the natural flora. They're in the environment. Vibrios are important, and like many groups of bacteria, there are some good Vibrios and some not so good Vibrios. Cholera, of course, is the most devastating of the Vibrio species, but there are other species that are pretty dangerous for humans as well. One is Vibrio Parahaemolyticus. This organism is found in the flora of fish and shellfish. And Vibrio Parahaemolyticus also causes a gastrointestinal illness. It isn't nearly as fatal as cholera. Perhaps you just get so ill you might wish you would die, but you won't. Another Vibrio is Vibrio Vulnificus. Now, this is the bad one. It isn't as common as the others, but it does appear at certain times of the year when the water becomes very warm and the nutrients are rich and high, and at specific salinities. These Vibrios are important to us in the environment. We just shouldn't ingest them. Now, why do they become infectious? We hypothesize it's because they are part of the natural gut and surface flora of crabs and shrimp and even the microscopic copepods. That is, they are found on shrimp and crabs because they are helpful to them, probably because they might influence and affect how they can move from seawater to freshwater, to osmoregulate. And what I would call an inadvertent or perhaps inappropriate host would be the human. And in the inappropriate host, as we know from other kinds of pathogens, when the human becomes infested and that's not the natural host, a disease will result. And I think that's what we see with the Vibrio species. There are a variety of environmental parameters or factors that play a role in Vibrio population size and distribution. Salinity is a key one. We found very early on, probably 25 or 30 years ago, that certain species were dominant in the northern part of Chesapeake Bay and other species of Vibrios down near where the mouth of the bay meets the Atlantic Ocean. And this clearly was related to the concentration of salt. Now, there are other factors that are associated with the distribution and with the epidemics. Heavy rainfall, flooding, and if there's turbulence so that there's a mixing of the sediment. These are all factors that play a role in the enhancement of the distribution and the growth of these Vibrios. And we have found that we can actually predict potential outbreaks depending on the climate, air temperature, rainfall, salinity, preceding the outbreaks by bursts of phytoplankton because of more sunlight, which will be followed usually and predictably by zooplankton, the microscopic animals in plankton, on which the Vibrios are abundant. And then if a human drinks water with those zooplankton and those Vibrios, then you'll have a cholera case. And then transferred person to person, you have an outbreak. So we can follow this and we can monitor it by satellite. So let's just use satellites to measure the peak time of chlorophyll and temperature and calculate out for that zooplankton bloom and then the cholera epidemic. And if we can correct and then match up with the numbers of cholera cases, it should tie tightly to the chlorophyll peak. Not that the chlorophyll plays a role directly, but that it's an indicator. And we were really amazed because the fit was remarkable when you consider that you were measuring chlorophyll miles up in the atmosphere with a satellite sensor. And you were literally counting the number of patients coming into the hospital and being confirmed as cholera patients. And those numbers, when you corrected for the time lag, were very close together. And then we refined our analyses to include rainfall, flooding, parameters of air temperature, putting all this together. And we were able to really get to the fine grain prediction that if the rainfall was of a certain magnitude, that you would have a correlated increase in cholera. And this proved to be the case. Now, if we change our environment so much that we start, as we are, having shorter winters, longer periods of high elevated temperatures, does this mean that we'll have much more cholera? I don't think, again, it's so simple because it's complexity that we have to address. The fact is that in developed countries, we have established interconnected systems for water treatment and sewage treatment, two very fundamental aspects of modern industrialized society. So if it gets hotter and there's more Vibrios in the water, our treatment system will deal with it until we start having, as predicted, and seemingly already beginning, severe storms. Then we start getting a breakdown of the sewage treatment plant, spilling over and contaminating the water treatment plant, or the river system from which the water is drawn and overwhelming the water treatment plant. Then we're back to pre-industrial times. Recently, we did a very interesting study. It was an international study and utilized an extraordinary collection of plankton set of samples that had been collected over the last 40 years by the oceanographic team in Southampton, England. The team went to Southampton, extracted the DNA from the plankton 40 years ago, 30 years ago to the present, and then used molecular tools to determine the presence of Vibrios. And we were able to find that as the sea surface temperature has been warming, Vibrios in the plankton increased, including the pathogenic species. And then we obtained the data from the public health laboratories in Europe, in France and Germany, England, Scotland. We found the Vibrio infections in parallel with the increase in the sea surface temperature increased. I suspect this is the first fully documented direct correlation of a climate change, sea surface temperature warming, with increased adverse effect on human health.